Today we're going to talk about solving for the density of a gas using the ideal gas law. So in order to do this, we have to do a little bit of deriving an equation. The important part of this is that you follow along, but then there is a final equation that we can use to solve this type of problem every single time. So since we're trying to solve for density, we have density is equal to mass over volume. And looking at the information given in the problem, calculate the density of ethane at a pressure of 183.4 kilopascals and at a temperature of 25 degrees Celsius, we see that we have a pressure and temperature. So we're going to want to use our ideal gas law. So there's a few things in here that we have to notice. One is that density is not part of the ideal gas law, which is why we're going to have to merge together these two equations. Now, pressure, they give us in the problem. Volume, they don't give us, but we see that that is part of our density equation. So that's how these two things are even going to relate. Moles is similar to mass, so we're going to have to relate these two as well. R is our ideal gas constant, so that is a known value. And T they give us in temperature. So what I want us to do is try to set up this ideal gas equation to be similar to our density equation. Now we said that volume and volume are the same, so we'll want volume on the bottom of the equation in the denominator, and moles is similar to mass, so we're going to want to try to get moles on the top. So if we divide both sides by RT, that's going to leave moles on top. So we end up with PV over RT is equal to N. Well, right now, V is on top of the equation, but we want it right under moles. So we can divide both sides by V in order to get an equation that looks like this. P over RT is equal to N over V. Now, N over V is very similar to M over V. Now, since we've done mole equations, we know how to convert mass to moles. So what we want to do is get this value right here to be similar to N. So we know that mass, if we were trying to figure out the grams of something, we would have to take the moles of it, which is N, and multiply it by the molar mass. So that's like saying that density is equal to N times molar mass. We're going to abbreviate it by capital M, okay, over V. Well, now we have NV, which is the same as this. To plug this into our equation, well, NV is equal to density, but now we need to get to this molar mass to the other side. So currently we have P over RT is going to be equal to density over the molar mass. So what we can say now is if we're trying to solve for density, we can multiply both sides by the molar mass, and we have the molar mass times pressure over RT is equal to density. So this is the equation that we will be using in order to solve ideal gas law equations that ask for density. So we have, in this equation, we have P, M, R, T, and D. The pressure given to us in the problem was 183.4 kilopascals. Now we need to figure out the molar mass of the substance. Well, we have ethane, which is C2H6. So the molar mass is 12.01 times 2 plus 1.008 times 6. So we have 12.01 times 2 plus 1.008 times 6, which comes out to 30.068. R is our ideal gas constant, and our pressure is in units of kilopascals. So what we want to do is we want to go to our chart and say, okay, the gas constant that has kilopascals in it is 8.314. Our temperature that's given to us in the problem is 25 degrees Celsius, but we know that we have to change that into Kelvin, so we add 273, and that comes out to 298 Kelvin, and our density is what we are solving for. So we have 30.068 times 183.4 divided by 8.314 times 298. So the density that I got here is 2.23 grams per liter, because we know that density has units of grams and liters.